Good morning. In this video, we are going to find the moment of inertia of a triangular lamina. So here is the lamina, okay, of height h and width is equal to b, and this is the axis x and y axis. Now, the area moment of inertia about the base axis ox axis is equal to integration of y square dA. Now we have to find the small element dA. Here is the small element. So this is the small element. Let me take this one as dA. Now if you look at the side, one side it is dy and this side is having equal to x, where x is a variable. Moreover, this small element is located at a distance of y from x axis. Okay. Now let us find the small element, area of the small element, this one, which is equal to dy into x or x into dy. So here is the answer, x into dy. Now I want to know the value for this x. Okay, again I am going to take the same triangle, but I have drawn in a horizontal manner. Here you see, here the total distance is h, and here this distance is y, so the remaining distance is h minus y. Okay, and here it is x and here it is b. Now with this data, the triangle is drawn like this. So here is the triangle, here this length is h minus y and here it is y. Now this total height is h. Okay, so here is the one, from this end to this end it is h minus y and here it is h. Next one is this is the length x, here it is b, so here it is x and here it is b. Now using the concept of similar triangles, okay, I can easily get the answer for x, that is x by h minus y, which is equal to b by h. Okay, and if I rearrange that time, I will get something like this, and again x equal to b divided by h, b will go here, so b divided by h into h minus y. Okay, so this is the answer for x. Okay, and I'm going to substitute into this equation, and you know that limits. So this is the area, it varies from, this is the lower limit 0 and the upper limit is, here it is h, so it varies from 0 to h. If you substitute these two terms into this equation, that is 0 to h and then x dy, in the place of x you just substitute this one, b by h into h minus y. So this equation will become like this. Now take this constant out, b by h, and multiply this y square into the bracket, so h y square minus y cube into dy. Now you just integrate this equation, you will get something like this. And if we substitute in the lower limit and upper limit and solve the remaining equation, you will finally arrive the equation of b cube divided by 12. So this is the formula for finding the moment of inertia with respect to base axis. Now I am going to find the moment of inertia about centroidal axis. Okay, centroidal axis means the axis will pass through the centroid. So here it is. So this is the centroid. Now this is the centroidal axis. Okay, here is the base axis. Now using parallel axis theorem, this is the moment of inertia about centroidal, base axis. This is the moment of inertia with respect to centroidal axis, and in the place of m, area is placed into d square, where d is the distance between these two axes, that is centroidal axis and base axis, and it is nothing but y bar. Okay, y bar equal to this total distance divided by 3, h by 3. Okay, now substitute into this equation. I have just brought this central axis in the left hand side, so this equation will become like this. Now a is equal to half bh and d equal to, it is nothing but the y bar value, which is equal to h by 3, and if you substitute into this equation, it will become like this, and upon simplification and solving, you will finally arrive the answer of ph cube divided by 36. So this is the moment of inertia with respect to centroidal axis, the x axis bh cube by 36, and this is similarly we can find the answer for y axis also, which is hb cube divided by 36. Please note that these are the moment of inertia with respect to centroidal axis in the triangular lamina. Okay, thank you. We will meet in the next video.